back. We are Java programming. It's COMP228, week 9, lesson 9, part 3. And I wanted to show you this code that we came up with from the last time. So we'll get back into this other stuff in a second. So let's try this out. We're going to go into lesson 8. And I've kind of put it up on GitHub so you can see it as well. But I want to show you the kind of a completed version of it so we can talk about it a little bit. And one of them is I modified the program a little bit too. So here's I called this thing, instead of what it was before, this is my to-do text field that I made, right? So remember, we made our custom class. So this is our custom text field class. And the reason why we made this is because, and it's again, it extends the JText field. So there's a regular JText field that we kind of extended, and we made it so that it had grid bag constraints, because we're going to use the grid bag layout for our app, right, that we're making right now. So all the stuff that we normally would have to put in for each text file or text field, I can only do once this way, right? So it's kind of from a code, replication perspective. We don't want to replicate code over and over again. We're going to reduce code. That's the one reason to use it. Okay, so I'll save that. And then the other one is I made a to-do window. It used to be called example window. I just changed the name to to-do window. And it has all the stuff, to create our window and so on. And if you look at the way we did it, and look at set hello label. That's not good. Let me rename this thing. Refactor, rename. Instead of set hello label, we're going to set message label, right? That's what it's going to be. Set message label. There we go. Okay. So set message label is what it's going to look like. And I've changed my hello labels to message labels because it makes sense that it would be a message. Okay, so in my add UI components method, right, this method here, it adds all the UI components, right, to the content pane, which is what we called to the content pane, right? And the content pane is a JPanel. That's all it is, right? So if you look at our hierarchy, if you go back into design view to see what it looks like, this is what our design view is going to look like right now. Very simple, the same window we've been using the whole time. Where you have the content pane, we have a message label, and so on. And by default, it's going to show one to-do field because I'm making a to-do list, right? Kind of thing. You guys are making a course list, and that's what it's doing, right? So I build it. I have my name label, my name text field, and my goodbye button. Really, this shouldn't be called a goodbye button right now, but it says click me, right? We're not doing anything with it right now. I could remove it. I have a to-do combo box and an age text field. And what I've done is I've instantiated the to-do combo box, and I've specified a type, which is a string, right? Before when I did it, I just kind of pulled it down. I didn't say what type it was. It was just a generic combo box. But the right way to do it is to pull it down and change this and to kind of indicate its type. So what's being contained in the combo box is a string, and that's what we did as a review. And then what we did was we were working on this scroll pane because we're having trouble with creating a scroll pane. Here it is. And we're also inside there, we're using a grid bag layout for each of our for the content pane, the J panel that we are calling to-do panel. The to-do panel is where all our to-dos are going to live, right? Now, I'm using an array list. So the array list is going to keep track of all our to-do text fields. And I can reference them this way, right? I'm also, if you notice, my text field has two values that it's taking in. One is a reference to the to-do panel that it's going to be added onto, and the other one is something called grid Y, or almost like the Y component of my level, my row. That's really what this is. So each of the rows, they start with 0, and in the bag layout, you have something called a grid X component, the column, and you have the grid Y component, which is the row. And maybe if I want to, I can change, refactor, rename this thing so to row, so you guys can understand what this is. So refactor, rename. We'll just call this thing row. Right? So we get the row and the to-do panel, and the row of my to-do panel is going to be added into the grid Y component by default. Okay? So that's what's happening. So those are the two parameters that I need for my constructor. And this is my constructor for my to-do field. It's the only one I have. I didn't have, it's not overloaded or anything like that. This is the constructor right here, okay? So when I call my to-do text field, which is right here, right, I have to pass in, again, a reference to this to-do panel, plus, on top of that, a row index, which is, right now it's 0, right? It's the first index. Now, I could use an enum, right? And I could say first, second, third, fourth, 10th, whatever. I could use that for my row, like first row, second row. But 0 is fine. I also have a message label that I set the text to say one to-do field. And what I'm going to do is I'm going to add more. As I add more to-do fields, it's going to change that message label. Okay, let's get to the meat and bones of it. This is it right here. So the first thing I want to do is I want to store, when I change my combo box, my get selected index, it's going to take that. So usually it starts at 0, right? That's the first selected index. I'm going to add 1 to it because that's the number of to-do fields I have in place. So if it's the 0th index, I have 1. If it's the 10th index, I have 11, and so on. And then I'm going to use this. I'm going to remove everything from my panel. That's the first thing I'm going to do. When I remove everything, it wipes it clear. So whenever the only time it removes everything from the panel is when I click that to-do combo box button. When I click it and I actually change the value, it clears the panel, not before. That's what this little event does, okay? And then what I do is I also use the clear method on the to-do array list, because array lists have a clear method, so you don't have to run through a loop to clear it up, right? So it clears it up like that. It's kind of built in. It's the best way to do it, to clear up your array. Why do I clear my array list up? Is if I didn't, because I add these text fields to my list, it would add in forever, right? So if I had 10, 15, 20, my array list would keep growing forever, right? I don't want that to happen. So I kind of clear it every time I come into this thing and click onto it. Then I run through a little for loop. Now there's many ways to do this. And I say, well, here's index 0. We're indexed less than the number of to-do fields, which is right now it's set to 1. Then I add that 1 to my a new anonymous to-do field is what I'm adding to the array list, right? And of course I'm passing in a reference to the value plus the index that I'm adding in, because if I add more than 1, it's going to be at the second row, third row, fourth row, fifth row. So I don't have to worry about absolute positioning, how we were going to do it before, where I can add a number of pixels depending on my position. That's kind of inefficient. In fact, if anything, we may want to eventually realign this whole form to make it a grid bag layout where we can set up rows and columns and so on. It makes more sense, right? For now, I left it the way it is. I have a message label, and then depending on the number of to-do fields, I kind of say how many to-do fields I have. And then one thing you need to have in there when you change a panel is there's something called revalidate, right? If you revalidate your panel, it repaints the panel, right? So when you've made changes to your panel by adding or removing components, it'll redraw everything in. If you don't put revalidate, then you won't see your changes, right? Even if the changes took place. Okay, so revalidate is one of those things we need to put in. It's another little method that redraws the panel back in real time. Okay, let's press play here and see how this works. That's what I'm going to show you later on. Let's go back here and press play on the real one, right? And again, I'm going to run this as run configurations. Let's see. Yeah, that's not cool, man. That's not cool. I know why, because my program.java file isn't here. Here it is. And I got to go run my program.java file, right? Hopefully that will work. There you go. So there's my little panel. If you notice, I've got you know, this little scroll bar because I've got 1 in there, and I've already gone extras in there already. So that's why the scroll bar is working. So if I add more, if I click this little thing and I go 2, it adds 2. If I go back to 1, it goes back to 1. If I go to 7, it gives me 7 that I can scroll through, right? And if I go to 10, which is the maximum that I kind of put in here, then it'll allow me to go up to 10. Now you can certainly program this so it can have as many as you want. If I resize this thing, you can see how it doesn't resize, right? Because I'm using an absolute layout, right? If I was going to use a different kind of layout and I want this thing, this whole, the fields and everything to resize or change position or be anchored to my layout, which is much more efficient, then I would use a different kind of layout. But the idea here is that these pieces, the to-do text fields, if you're going to do it my way, and my this to-do window, which does this, you know, combination of detection and updating automatically, my to-do array list, By the way, if I wanted to know how big my array list is, how do I find out how big my array list is? That size, right, for array list. So let's print that out just to show a little bit of, you know, kind of thing. So let's see how big it is right now every time, right? So I'll say system dot out dot println, and I'll say, you know, the array list itself is this dot underscore to do array list dot size, right? And then that'll show me the size of my array list, right? After I do my redraw. Actually, let me do that after I do my redraw, which is right here. So the last thing I do before I leave this function is I draw how big the array list is. And the reason why is if it is growing, then I know I've done something wrong. It should never grow. It should go smaller or bigger. The number of items in the array list should only be there according to the size. Now, why do I use an array list? We're going to talk about that as well, because some people are like, you don't need an array list, right? Okay. Well, let's see, right? So one thing is, I don't see the number here because I haven't gone into that function right now. Like right now, as an example, you notice that there's nothing in my console. Well, that's okay because I haven't clicked on this button yet. So if I click on this thing and go 1, then I have 1. My array list is 1. If I go to 6, it should be 6. If I go to 10, it could be 10. And if I go back to 1, it should go back to 1. Now that's kind of the trick. How do I clear the array list and add those things in back in there? All right, so that's good. I mean that the array list thing is working. I know that I'm not going to kill my computer by continuously adding to my array list. And this is a small example, but in a larger example with thousands of records or something like that, you never want to make your array list get out of control, because otherwise you just take resources for no reason. Okay, number 2, how do I access now that I have those fields in play? How do I access this my field? So when I type into it, I type into the field, right? This is the second part of what I want to do with you guys today. After I type into the field, I want it to output into my message label. So anything I type in. So this is a random field. So this is a field that I'm adding into dynamically, right? So this field doesn't have right now. It doesn't have any kind of way of listening, and I'm doing that inside of a listener, inside of an action performed action event. Careful, right? So how do I do that normally? Well, if I was to go up here to because I have to be able to respond to this thing or contain, the data somehow, access the data. I notice that I have this .name text field, add action listener for each different thing. The goodbye button, the age text field, the to-do combo box, all these things have action listeners attached to them, right? How do I add action listeners for all of these, right? So I have a bunch of action listeners that I want to add. And I also want to remove my action listeners when I'm done. When I reduce the size of my list, when I do one of these clear things, I don't want to keep adding these listeners forever, because then I have a bunch of these threads that I have loose threads, literally, like that are just sitting out there that are taking up space, right? Almost like sub-processes going on. And what I do is I go to the thread pool equivalent, right? I grab a thread and I say, I want to run my event listener in this thread. Or I want to start listening for this stuff. And I'm taking up CPU resources when I don't have to, right? So how do I do that? So again, remember, this is an anonymous field that I'm adding in. I'm only adding 10 of them. But the good thing is the array list has a number of them set up. So if I want to look at the first one, right, then I can add in, as I add this to the array list, to do array list.add, I can also add the event listener, right? But here's the challenge. The challenge is that I have no way of accessing the to-do text field because it's an anonymous object, the way I've put it in. So what do you recommend?
Can you add the event listener to the to-do text field?
By chaining, you mean?
No, in the actual to-do text field class.
I could. So you mean right in here, when I add this event listener, and I can add it in here. As I create this thing, as I add it to the panel,
yeah,
I can create it. That's definitely one option. That's a good option, right? I want to be able to destroy my class, my objects, though, somehow. When they're gone, I want my event listener to go away too, right? How do I do that, by the way? If I add an event listener, can I remove one? So let's go back to my, because remember, this is all kinds of event handling, right? So here's my to-do box add action listener. Can I remove it? So if I say this underscore to-do combo box dot remove, right? Action listener, and notice how I can, right? I can do that. And if you realize, the reason why I want to add or remove an action listener is, again, it's overhead, right? Normally, for us, for these 10, you're 100 or 1,000, still not going to matter in the greater scheme of things. It doesn't matter, right? But in terms of cleanup and being nice, to our fellow users, right? We may want to remove these event listeners. Now, here's the thing.
They don't get removed when they're removed from the panel?
Well, no, right? Because I'm adding a listener. I'm adding a listener to the option, right? So even though there's nothing to respond to, I can't click on anything. I can't do anything with it. It's taking up actual memory space, right? That's the thing to note. That's why you have the remove action listener there in the first place, right? So otherwise, why bother? Why bother removing them if I have them? If I keep adding them, I've added them once, which is good. Your way, the way you're thinking about doing here, I'm going to add them every time I add. I'm going to keep adding new listeners every single time.
Right. And then is there an equivalent of a destroy?
There is. But I have to make sure that it won't destroy my listeners that I've added in automatically, right? So if I have an array list, and the array list has objects, here's what we're doing. We're doing composition here, right? Again, so class composition is where I have a little class that I'm using. And I'm using that class as an object of another class composition, right? Composition. So this is cool and all, but the problem that I'm having is that if I add an event listener here, I'm always going to do that every single time. Every time I add a to-do text field, I'm going to add a listener, right? And it won't go away, right? It'll never go away. But it'll be one that's linked to that particular event, right? And it's going to be an anonymous listener. Let me show you how this works. And by the way, here's another thing that we have a problem with, right? When I detect which one it is, here's my action performed listener, right? I'm detecting which one I'm doing, right? And if I use this one, this action performed listener that's part of my class, this class, right? How do I detect if the get source is equal to this name text field? Because you know what? These text fields are going to be I can't detect them. They're all going to be different ones.
You have to look through the whole array.
Yeah, there's no way, right? I have to go through each one of them. It's almost like I got to go through them all and check them each. I got to check each one of them to see which one it is, right? Is it this one? Is it this one? Is it this one? It's too much, right?
Or you could get source. Is there a get class from the get source, and then you can see if the get class is equal to do text field.
Okay, let's try it out. I like that. I like your thinking. So if I was to pre-code this thing and to just to prepare for what I'm thinking about doing, and again, if I was to do it down here, let's try it out. So I'm going to say if event dot get source. Now if I go back, these are the ones I have. Get class, like you said. There's my get class, or whatever the event is. And notice that my get class has to be, when I put it in, it gives me the kind of the code hinting for get class, where a class is of a class type, right? So if I click onto it, it says returns the runtime class of this object. The return class object is the object that is located by static synchronization methods of the represented class. And here's an example. So num n is equal to 0, class extends number, right? This, whatever the number is, this is a generic method, C. And then this is a neat way to do it too, by the way. If you ever see it like this, this is like you can extend a class right here inside of when we declare, like almost like a generic, right? And then when we say is n.getClass, and what it's going to return is it returns the class object that represents the number class of the object, which is number. That's what it's going to return. That's the class. That's the originating class. But that's going to handle for every one of them. Every one of them is going to have the same class. I'm going to have 10 of them. They're all going to have the same class.
Yeah. Yeah. No, it doesn't. It wouldn't matter because then.
What is it?
You do that. Is there a get source dot get class?
Let's try that out. So get source events dot get source dot get class. Right now, what this does is it get class again is the same. so I can be specific to the kind of object, right? So I'm listening for a type of source, and if it's equal to, you know, the, but I gotta be very careful. What kind is it? It's an anonymous object here that I'm doing, right? See where I'm going? Like, there's so many ways. How about if we make an anonymous event listener? How do I do that, right? What if I do it here? If I say, when I add this thing in, I want to also add an anonymous listener. How do I do that? So I'm going to say this, but I can't do an array list. You know, I can't look at the array list. I want to kind of look at the to-do field or to-do text field. I don't want to give this a name, just a variable, right, that I want to kind of use and then discard, right? So it's not going to be something that I care about. It's going to be the same variable name, right? I'm just going to be using it as a reference because this is a reference type. It's not a value type, right? So let's kind of instantiate an object of type text field or to-do text field. So we'll say to-do text field. We'll say to-do text field, right, is equal to new, this thing here, this line here that I got right here, new to-do text field, blah, blah, blah. Hear me out why I want to do it this way. So I'm breaking it out into 2 lines now instead of 1. And then I can use this as a reference to this object that I just created, put it in here, right? And now I can do this. I can say to-do text field dot add action listener, right? And then in my action listener, I want to make an anonymous action listener, which is going to be a new action listener if I can, a new action listener component, right? Which does this, right? Automatically. When I create it, it goes boom. When it creates an anonymous action listener, that's right in here, which is action performed. So now I know that when this happens, this new action listener, it hits this anonymous class, so I never have to refer to it, right? And I can do something like, you know, this, and it should know about my stuff. So if I go this dot underscore, look how this is a problem now. How come this is a problem? Scope is different. I can't use this, but can I use something like this? Can I go, I want to access my message box, my message label. Can I just say underscore message label? Can I do that? Underscore, if I have access to it, I do, right? Dot set text. That's why I use this keyword a lot. And then I want to set the text to, you know, whatever the text is that they're typing in, right? So for example, remember when he's typing in text, in order for this text box to fire, they're typing in text, right? So I want the get text of this text to do text field. So to do text field. If I have access, I may have access to that. To do text field, I do. Got get text. Right. Oof. Right, but it's an anonymous class. This is equivalent to doing an anonymous, you know, it's kind of buried deep, but it's an anonymous inner kind of, you know, anonymous listener. That's another way of doing it. And I'm doing this inside of my listener. Here's my action listener itself, my action perform listener, right? So this is kind of what you can do, right? So now I'm creating them, but in this particular case, I'm never destroying them, but it's part of, each one of them has its own link to it, right? And this way I don't have to ever, I mean, I can do the same thing you said. I could have gone into to-do text field and added it here. Exact same, right?
You wouldn't have to.
But this way is what I'm saying is I'm actually naming it and I'm adding it in here. That might make some sense. I wanted to show you this notation, by the way, too. Like, because otherwise you would never have seen it. And then you would have been like, he never showed us, right? Okay, so let's try this out. So let's see if it works first of all. So when this means that if I click here and if I go blah, 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 and enter, then it should change my text field, which it does not. Otherwise, you know, this is what I would add. Now this is neat because this only works for ones that I add in, but not for the first one I added in. So this is where I would go back to your method. Let's try it out anyway. Let's go back here and add a new text field. So say I want 2, right? So wipes them out. I put this and press enter and it does it, right? And I go to the next one and press this and it answers that too. So that's, each one of them has a different value and I can access these values depending on what I type in here. Each one of them has their own action listener as I add them in. And if I reduce them back to 1, and I go back to here, and I can go back to here, and it'll add that one in too. So each one of them has my action. But the problem is,
the action listeners
they're there forever. Even though I've destroyed the action listeners, they're there forever. And there's no way. How do I get rid of that to purge them? And I have to create an event for that. I have to create a little bit of a, something I've got to call to remove them all.
So extend the
Let's do it. So now this piece here is kind of cool, right? Because this inner, it's almost like an anonymous action listener that I've created, and I've broken out this to-do text field. I can leave this here the way it is, so we don't have to make too many code changes. But I can totally get rid of this. This is not what I want, right? Because that's not going to allow me to remove or add or whatever. And that, especially not my first one. My first one, because I had a default one up here, which is here. This is my default. I add 1 to the array list without adding a panel. This one will work. And if you do this outside of the loop, outside of the event loop, it won't work. It won't do that thing I just did. So I don't want to do it again and again, right? So how do I do that? So let's go back to my to-do text field. And there's a couple ways I could do that. I could implement, like the way we did before, and I could implement my my event listener again on this class. So remember how we did it here on my to-do window. It can have its own action listener. So I can implement its own action listener. So let's try that out. So I say implements action, and if I press, the one I want to do, so extends text field. Extends the text field, but I implement my own action listener. Now here's a question: can I do it? That's the question. So implements action listener, and it says if I hover over, it says create class implements. How about lowercase I? Would be nice, right? And the other one, it says action listener cannot be resolved to a type. Import action listener from java.aw2.event. I do. And now, of course, it gives me an error here because it says you have to add the unimplemented methods, which I do, which gives me the space for this action perform method that this thing is going to put in. So anytime I have an action listener, it's part of it. As soon as I create my text field, I automatically have an action listener that goes along with it. So I don't have to create it by myself. Now, there is no way for me to remove the action listener because I'm implementing it with part of my class. It takes up space, takes up memory.
Is there?
The user presses enter in one of the text.
But then that means I can never do it again?
No, when you do the remove all on the pane.
Yes, that's when I want to do it.
The action listener doesn't. So is there an equivalent of a destructor?
We'll talk. Yes, we'll talk about that. So let's go back. So how do I do this? So how do I? First of all, I want to be able to access my message box. And notice how I'm doing my action perform. I have my to-do panel, and I got my row, and in my parameter list here in my constructor, I need access to that thing too, right? Which is my message box, my message label. Otherwise, it won't spit out anywhere. Now, this is my code the way I made it, right? Obviously, yours will not have to be there. So, but if I want access to it, then I have to go back to here. And if I know I have to pass a reference to my message label, type J label to it. So I want to say, okay, so fine, pass me a message label where it's going to go out of. This is a specialized little function we're making. So J label, we'll call this message box or message label. Here we go, message label. All right, so this is a J label. If I hover over it, says import the J label class, which I've done now automatically. And now that I've got a reference to J label, I got a problem. I got to go back to this and fix my issues. One of them is I have to send in a reference to J label, right? So I got to say this dot underscore message label. I got to send that in there, and I got to do the same thing. Did I send in a weird label? What did I do? Oh, this is undefined. It says int J label. I did define it. Oh, I didn't save it. Yeah, J label, message label, and then that would work. And now I got to do the same thing down here with these ones. because I gotta have a reference to this. There's a lot of references. Can you recommend something else? JLabel. Right. Lots of references to the stuff. Not JLabel. Message label. I'm getting tired. Message label. And then if I go down to here, right now that I have access to it, I can print out to it. I can say something like, when I click onto it, I don't have to even do an action performed. Anything that hits this thing will go out to it because it's the thing for the text box that I'm making, right? So I'm going to say something like this. I'm going to say, now, well, here's a problem. Message label comes in here. I want to have access to it here. Do I have access?
No.
No, because here, this override function, which is a separate method, an event listener or event handler, isn't accessible through the local scope that is my constructor, right? So I got to create another private. If I want access to it, I have to do this. So I'm going to say something like, here are my private instance variables. I know it is, but that's how. This is the thing. This is what you have to think about. How do I do this stuff? How do I implement? If I have a problem, I got to solve it. How do I solve it, right? I could create a private instance variable that's called as of type JLabel. So I could say something like JLabel. Yeah, private. Thank you. Private JLabel that I could call the same name, message label. Doesn't matter, right? And I could use an underscore because that's my system that I use. That doesn't have to be. So when I get it through here, I can make an equivalent of it like that. So I kind of say something like this. Well, this dot underscore message label is equal to message label. Could do that. That gives me a reference to the message label that we're talking about here, right? Now, when I'm in here, I can access it by going this dot underscore message label, right? Dot set text of my text, which is this object, this whole, oh, I gotta be careful now. This dot get text, this one, because this object is a text field, right? Therefore, this object has text, and therefore, if I get text on it and send it to the set text message or the message label, it'll print out. All right, let's see if it works.
Yeah.
And this is all dynamic. It's not doing it on the fly as opposed to the way we did it before. So let's go back and bring up my program file and play. And now, even here, it should work, right? So if I say something like Tom, right? We did it. So now we do some troubleshooting, right? Well, we have to do some troubleshooting. So go back to here and let's do some, first of all, where is it happening? So this thing here is happening inside this action performed method that's attached to this object, but we didn't do a this dot add action listener. Even though action listener is here, we still have to do that, right? And we have to do that in the constructor. So as soon as the do panel is added, we're adding this to the to do panel with the constraints. We still got to say this dot add action listener. We have to do that to this. That's what we have to do. If you don't do that, then there's no action listener ever added, right? That's another piece that we haven't done. And then now let's run that thing, see how it works. Okay, so now we go here and press Tom, and now we're good, right? So again, we've built up our class. This is a great way of looking at composition, right? Because we've got this, you know, we've implemented or good, really nice polymorphism in interfaces because we're extending our J text field. We're implementing our action listener, and then you know here we're having this action listener on an anonymous object, right? That we're adding in because we don't care. It's part of the object. Every object has a bundled action listener that we can do things with, right? Now the challenge is how do I delete my action listener if I want to take away my action performed? How do I get rid of it? I cannot do. I have to get rid of it by doing this. This add action listener has to go away. So how do I destroy or do some cleanup, right? Because I'm doing this in the constructor, I almost have to have a destroy method that I have to fire, right? That destroys my object, right? And let's take a look at the destructor methods here of Java. So if I look up destructor Java. Right now you were being very typically for the destructor, it's happening. For destructor, the garbage collection happens automatically for Java, typically. But in this particular case, it'll keep growing and growing until finalize. Yeah, that's what it is. Finalize. You know, when do we finalize the object, and how do we emit finalize for it to work, right? So if that's the Java destructor, how does it look? This finalize statement. So finalize throws throwable. That's what it is, right? And then system.out.println object is not eligible for garbage collection, and all is still active. And the reason why we don't use finalize and that destructors are, in general, they're looked down upon, because Java takes care of its own garbage collection. You want to be able to destroy. I mean, if you're going to use a destructor, so something that deconstructs something, that's what a destructor is. We don't want to do that. It's going to be destroyed anyway, the object, right? But that doesn't mean that my action listener is going to be destroyed. How do I remove that manually if I wanted to? Even though I've
part of the class though, right? So
yes, it is, and most likely you're right. It'll be cleaned up by garbage collection around in the next tick or so, right? But what if I wanted to? What if I wanted to get rid of my action listener? I want to remove my action listener from this anonymous class. How do I do that? From each one of them. I don't care which one, but I'm going to remove them all, right? How would I remove them all before I kill my array list, right? So I'm killing my array list. They're all in the array list. That's why I have the array list, right? So I can do stuff like object pooling like I'm doing right now, right? So I want to kill them all. How do I do that? So go back to my to-do window. And before I do this, before I do the clear, I run through each item in the array with a for each, and I perform a method, which is remove this dot, remove thing. And I'm going to do that by making a public method in my to-do text field. So let's make that. So we'll call it a public method, public void, and we're going to have it. We're going to call it something like something that doesn't make any sense for anything else, but something like a remove event handler function. Doesn't exist, right? So as long as it doesn't clash to anything else, we're good, right? And what this event handler is going to do is going to say this dot, because we won't have access to this, remove action listener. That's what it's going to do. This, right? That's what it's going to do. It's going to remove it from the method itself. And in order for us to check that that's happening, right, we're going to make a little system.out.println. See all these things that are happening, and we'll say action listener removed. Action listener removed. So that's what it's going to do. That's what this system.out.println is going to do. And it's going to access this public method, this removed event handler, through a for each loop. So let's do this enhanced loop before we do a clear. So we're going to do one of these. We're going to say, we don't care how large the array list is. We don't know how large it is. But we want to get rid of it all. So we're going to say, let's say we'll do a for each. We'll say control space. We'll look down where it says for each, which gives us our enhanced listener. And notice how it puts in this to-do array list because it's the closest one it can find. And this is why Eclipse is a little bit smart that way. We're just going to clean it up here. So to-do text field is to-do text field, which is not like this to-do text field over here, right? It's a different one. Only for this for loop. That's why. So the scope is only for here. And what I want to do is for each to-do text field, I want to perform that little public function. So I'm going to say to-do text field dot remove event handler. Right? I want to do that for each one of them. So it's going to clean up all those little event handlers before I clear my list. That's what it's going to do. It's going to clean them all up. We don't care which one it is. They're all going to be gone, right? Because we're clearing the list anyway. So I might as well clear them. That's why I use my array list. My array list is used for me to control my objects, just unless I want to do that. That's why people ask, well, you don't need an array list. You're right. I don't need one, right? But I can use it like this, and I can access my objects this way with an array list or some kind of array in order for me to remove them. An array is not a good it's not a good fit for this this program that I'm making right now. An array list is a better fit because it's more dynamic. I can add and remove objects. In this particular case, I'm removing them all. And I keep low in terms of, I don't know how big my array is going to be. In your case, you want to make it 1,000. An array list is the perfect structure for that, right? 1,000, 10,000, whatever you want to make, right? Let's see if this thing works. So I'm going to kind of go in here so it doesn't crap out. Kill this other one. Hold on. I've got a couple of them that are running. That's one thing I don't like. It doesn't kill the other one. All right, so let's run it again. So there, and I type in a name like Tom there, and that's it's my little to-do list. If I keep typing, call the wife. Okay, my to-do list. Right? Call the wife. It's there, and then, but I want to change this to something else. Let's keep track of my console for a second, see what happens. Once I change this to 2, right? Action listener remove. So it actually ran through that function. We know it did because it went and it did that remove event handler, and it added 2 more, right? It added 2 more. So now we've done some simple, garbage collection, if you will, to make sure that we keep track of our stuff, that we don't go over and all that kind of stuff. It's good. These are good things to think about. Doesn't matter if you're making a game, and we do a lot of games here, or whatever. It doesn't matter if you're doing firing bullets, right? As an example, with in a game where you fire a bullet and you keep track of a object pool for the whole bullet. So the bullet's there, and then all you do is reset the bullet. And if the bullet has some kind of effects that are on it, you want to take those effects away before you dismiss the bullet, because there's other things going on in the background. You're borrowing a thread from the thread pool, and you're never returning it back, and that can cause memory leaks later on, which you don't want. In an Eclipse program, a desktop program, like you're saying, who cares, right? Because it's gonna.
I'm saying in this case it would be cleared up automatically when the task.
Maybe. How do you track that? Right? And so we'd have to look at the other.
That's what I was thinking.
There's other ways to looking at things to check and see if it's done. But on Android devices, you'll see that all the processes that are running in the background. So if you ever do any Android programming, you want to remove all event listeners. You want to remove all those things, because any one of those things, and that's why we're doing, because Java is step 1, right? What we're doing here. Next step, you maybe do Java EE, or you do some Android programming with Professor Ilya, right? So if you do any of these things, then what you want to try and do is you want to clean up all your code, make sure there's no memory leaks, because in an Android device, it'll shut you down, right, after a while. Because remember, you never shut down the app on an Android device. It's always in the background somewhere, right? Even though it goes dormant, it's still there, right? So unless you physically shut it down, you never shut it down in iOS either. Both iOS and Android, the app stays dormant on your device, on your smartphone, right? So because of that, you want to take care of memory leaks like this, potential memory leaks. We don't know, and it's good practice to clean them up anyway. Whether you don't want to assume that the machine's doing anything for you. All right, we don't know what's happening right now. Maybe it is, maybe it isn't. You're thinking it is. Maybe it is. Maybe you're right. Maybe you're not. Right. So that's the thing. So until we can do some kind of process evaluation or whatever, we do some more in-depth testing, which we haven't done here, or we can't tell. Okay, any questions around what we've done here? I'm going to just go back and take that little system out, that print line out, and then I'll upload to GitHub so you have this solution. So any questions around what we've done? This solution may not be made for you, right? So if you're doing this course stuff that we're doing for assignment number 4, it's not the solution for assignment 4, but it gives some hints of what you can do, the same kind of things we're talking about here as an example, to make you successful by creating something for assignment 4. UI, whenever we create UIs, it can be very complex. It can become very complex. And as you see when we start doing Java effects tonight, it's even more complex, right? Because there's some, it just builds, right? This is part of what we're doing here in Java. We keep on building onto it. Next week, we're supposed to be starting database as well, right? For the first time. So imagine we're going to have a database with JDBC, and plus we're on top of that, we're going to have Java effects. We can build a monster program eventually with it, right? What was that?
Isn't the pace of the course too fast?
It's assumed that you already know object-oriented programming because you've taken it in C#. It's assumed that you know interfaces and polymorphism and arrays and array lists, generics. There's a bunch of stuff you should know. Forms you've already done, Windows forms somewhat, right? So really, all we're doing is reviewing it from a Java perspective. So really, is the pace fast? I would say no. if you don't know your C# good enough, then yeah, it's pretty fast, because now you're playing catch up with the stuff that you should have known from last course, right? And there's only a few new things, like JavaFX is a new thing. Some nuances with the language for Java, that's new, like the way things are. Eclipse, that whole IDE with Eclipse, which, to be honest with you, I'm not a fan of Eclipse. I'm better off with something like IntelliJ. I like IntelliJ a lot more. It's more organized. But remember that we use Eclipse for Android somewhat. We also use Android Studio, which is IntelliJ, right? But you know what? More or less these days, it's good to start with Eclipse, because Eclipse is the kind of the standard, if you will, that's used everywhere. And it's easy to move from Eclipse to IntelliJ, and you'll love it. When you go to IntelliJ, you're like, oh, wow, that's a little better than Eclipse, That's why I like it. And it's more of a professional grade program, right? So we'll talk about IntelliJ a little bit. And if I was going to kind of include IntelliJ in here, what would it look like? So let me just upload this to GitHub so you see that. So I'm going to go to team, and I'm going to go to commit. And in here, I'm going to say updated to do text field, or added, I'll say added event listener handler to do text fields. Yeah. Commit and push. Now you have it all. Questions before we take a break? So I'm going to take a little break right now and have a little bit of water, and then we'll come back and we'll start doing JavaFX for the next hour.
Did we have to use one?
No.
Okay.
I never said you had to do an array list.
Okay.
Right? I'm using an array list for control, right? So I can go in through, and if I want to keep track of it holds as a container for all my anonymous objects, right?
Right, but
it's good practice.
You can get all the objects that are inside the pane, right?
You could, because the pane itself has a display list. So you can have this almost like an object count, if you will, right? So you can actually count which objects there are, and you can clear up the pane. You can do all those things. But then again, you're assuming, again, if you go back to your to-do window, and when I do my remove all, you're suggesting that all the objects are gone, right? Where do they go?
Right, but it's the same thing with yours, though. When you remove all, and then you're also removing from the array list.
When I remove from the array list, it actually destroys the objects, right? Because they're gone. Those objects are poof, they're destroyed, right? These.
Right. But then they're being added to the pane separate from the array list.
Correct. But the array list is keeping track of them all, right? It's almost like the way I can control whether they exist or not, right? Because otherwise they're anonymous objects that are being added to the pane. When you get rid of them, do you really get rid of them? That's the challenge. You don't know if they're really going or not, right? Right. It's almost like, if you think about it, if I don't do one of these, this to do panel revalidate, I can still type in there and everything. The object still exists, right? It doesn't stop me from typing or even causing an event to happen until I revalidate. As an example, that those objects are still there; they're still working, right? If I clear them up, it's one thing. But if I add new ones or whatever, the old one's still around until I revalidate. And revalidate, this piece right here helps us because we know that it does some garbage collection. We know that it goes around and it redraws. Look what it says here: calls invalidate, and then adds this component's validation route to a list of components that need to be validated. Validation will occur after all currently pending events have been dispatched. In other words, after this method is called, the first validate route, if any, found when walking up the containment hierarchy of this component will be validated. By default, J root pane, J scroll pane, and J text field return true from is validate root. And blah, 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 blah. And basically what it's doing is it's going through there and then redrawing the UI. That's what it's doing when it revalidates. This is something that's Java specific. This is not something that happens in C#, okay? And it doesn't happen in JavaScript. All right, if you were to do JavaScript, C#, if you did it in another language, C++, you don't have an invalidate or revalidate. C++ is just even worse. You have alloc, dealloc, and stuff like that, where you allocate and deallocate memory. I like it more because you have more control, right?
You know for sure.
You know for sure you're taking care of your garbage collection. Here, it's being taken care of for you, and you don't know what's happening. Even in C#, you don't really know, right? You think you know, right? But you don't know for sure. Okay, so let me pause it there and we'll get back. But yeah, to answer your question, do you need an array list? No. Should you use an array list? Probably, right? Only because you want to keep track of your items. You want to keep track of all your components. And you want to have control, like for example, to do something like this, which I did with my, this part here, right? Which I ran through my array list to access my, each of my to-do text fields, my anonymous fields, to remove them.
Still do that with admin.
Without adding an array list?
Yeah.
Well, you could access them through the actual JPanel
Yeah.
as objects. That's the other way to do them. But this is just easier, right, for people. Right? But it's, again, actually, all you're doing is pointing to the same address.
Yeah,
Right? As long as you have access, you know how to access them. Yes, you're right. You don't have to.
I guess still the same thing because it returns a collection.
Correct. All you're doing here is you're just repointing these anonymous objects, and you're grouping them with this other collection as well. So they're part of this. They have this other set. They're part of the first set plus the second set, and you can clean them up. Okay, let's stop it there, and then we'll come back and start off with.